in Math 1000, in the class Math 1000. This is where we're doing quite a bit of factoring. And I know sometimes with trial and error method, factoring can be a bit confusing. So I want to demonstrate working through the AC method and then also using trial and error on several of these problems. And then I'll also try to look at a few problems from the review as well for exam 1. So I'm going to be sharing my screen so you can see where I'm working. All right. So I went ahead and just printed out some problems. Let me remove the pages beneath so that they don't show through. Okay, so the first problem here, the first couple, it says factoring a perfect square trinomial with leading coefficient greater than 1. So even though this may look like it would be more difficult, I want you to think about perfect squares. I want you to think about that the first term is a perfect square as well as the last term. So if you'll pay attention and notice that, then that'll make this problem go a bit easier, okay? So also one other thing is you'll notice that the constant term is a positive, which indicates that we're going to have like signs in our binomial factors. So remember the way we factor it. Now, of course, you would always try to look for a GCF, a term that or a term or a factor that could come out of all terms. You would pull that out first if there was one. There isn't one in this case. So then I examine it by noticing that my first term is a perfect square as well as my last term. In other words, there's one number that I can square and get this same thing here. So 49v squared is factored as 7v and 7v. Okay? Now, keep in mind, this constant term is positive, which means I have like signs, and then this sign tells me what they both are. So like signs, both are negative. So because they're like signs, you can go ahead and put both in. And then the factors of 1, or 1 being a perfect square, when you square 1, you get 1. And there's your factorization. Now, they may want you to go ahead and simplify this and express it as 7v minus 1 squared. It is possible that they want you to write it using one actual binomial factor and then square it, okay, because they are the exact same. So looking for problems like this, they may just say factor, but I want you to take note that first term, examine the first term, notice that it's a perfect square, and examine that last term and notice that it's a perfect square. And then also that constant term, when you're dealing with a perfect square trinomial, that constant term, that C, will always be positive. And then the middle term will tell you what both sides are. So I'm going to go right into my binomial factors again here because, again, there's no GCF. 25 is not a multiple of 2 or anything, so I can't pull out any factors from all. So I go right into my binomial factors. I factor 36x squared as 6x and 6x. Okay? Then, because I have a positive C, I'm going to go ahead and put my signs in. Same signs or like signs. Okay? And that tells me what they both are. And so 25 is 5 squared. So I have 5 and 5. And let me just verify this, okay? You verify to ensure that you get the right factorization or that you got the right factorization by checking the inner and outer products. Together, the inner and outer products should give you that middle term. You already know the first and the first gives you the 36x squared because you factored that. And then you already know the last times the last gives you the 25. To ensure that it's perfect, to ensure that it's correct, you check the inner and outer products, and those two added together are supposed to give you that middle term, that B term. And this does. You've got a negative 30x and a negative 30x. Adding those up, you get a negative 60x. Same thing here. A negative 7v and a negative 7v for the inner and outer products together give you that negative 14v. And then because you've got 6x minus 5 twice, you can just express that as 6x minus 5 squared. Okay? Now, these next few problems here, where we're factoring a quadratic with a leading coefficient greater than 1, these are the ones that I use trial and error. I showed a few of these in class, the class meeting before last, but I want to show you two different methods. I want to use trial and error, and I want to use the AC method, and then you decide which you prefer. And so when you're on the problems, when you're working through the problems, in the ALEC system, it actually gives you an option. It says explanation or different explanation. So it will explain the problems to you using the AC method, and then it can also show you the trial and error method. So you decide which you prefer, okay? So I'm going to try the AC method first. Now, to use the AC method, of course, let me start here. You always look for a GCF, okay? And there isn't one. There's no factor outside of one that can come out of all three of those terms, okay? So then we go into the AC method. So we have the A, okay? The A coefficient is 3, the B coefficient is 1, and the C term is negative 2. So A is 3, B is 1, and C is negative 2. So the AC method tells us to multiply A times C, which would be 3 times negative 2, and we get negative 6, okay? Then find factors of negative 6 that give us the B, that give us B, which is 1, okay? That will add to give us 1. I should have said that. Add, and maybe I need to say slash subtract, because they may have different terms. And of course, they may have different signs. And of course, when they have different signs, they technically are subtracting to give you the middle term, the B. So factors of 6 that will add or subtract to give us B, okay? So we need, and it's negative 6. So what we're going to do is use the terms that we have, 3 and negative 2, the numbers that the factors that we actually use, the A and the C. So we're going to say negative 6 is a positive 3 times a negative 2, and 3 plus a negative 2 does give us 1. It does give us B, okay? So I'm going to use those two numbers, those two factors, and I'm going to break B apart. I'm going to separate B into two factors so that then instead of having 3 terms, I'll have 4 terms. Let me show you. So I'm keeping the 3y squared, okay? Where I had, and there's an invisible 1 here, where I had 1 for B, I'm now going to express it as 3y and negative 2y. B is 1y, the coefficient is 1, and then it's the y term. So instead of expressing, let me rewrite it for now. Let me write it like this. So I'm going to express this as, so I got 3y squared. I'm going to express that 1y now as positive 3y plus a negative 2y, and then I got minus 2. Okay? So instead of having just 1y, I broke or separated 1y into 2 separate terms using factors of negative 6 that add up to give me this 1, or subtract to give me the 1. In this case, I'm technically saying subtract or adding because this is negative. So now you can see that I have 4 terms. Now we have 4 terms. We can use factor by grouping. So this is the AC method, okay? So now that we have 4 terms, factor by grouping says that we break or we separate these 2 or these 4 into 2 groups. The first group plus the second group. and you take that negative sign with that 2, which is why I put a plus in between. So now I look for a GCF that comes out of this pair, which would be 3y. And that leaves me with y plus 1. When I factor out 3y from 3y squared, I'm left with a y. When I factor out 3y from 3y, I'm left with a 1. And then over here, they have negative 2 in common. So I'm going to pull out negative 2, because remember, your goal is to get these binomials to match once you do factor by grouping. So then I'm going to pull out the negative 2, and that leaves me with y plus 1 right here as well. So my factorization is now 3y minus 2 times y plus 1. That is the AC method for that number 3 problem. Okay? I'm going to show you the trial and error method as well. So I'm going to do that same problem. Let me kind of cover that up. Ignore this right here. I'm going to work that one in a minute. So I'm still on this one. This is the AC method that we just demonstrated. Let's do trial and error. Okay? So for trial and error, we've got 3y squared plus y minus 2. So again, no GCF. So we go right into our binomial factors. So I'm working this same problem, but I'm using trial and error method now. Okay? So to factor 3y squared, I know it's going to be 3y and 1y. Okay? Now, I look at C and I see that C is negative, or I recognize that C is negative, which means I have different signs. Now, because they're different, where you place them matters. So I'm not going to put them in right away. Okay? I'm not going to put them in right away. Now, what I'm going to do is look at the factors of 2 and where I want to place those. And if I have more than one factorization, then I may would have to play around with a couple. But 2 only factors as 2 and 1. So that's good. Now, where I want them, that's important. Where do I want them? That's the question. Okay, so factors of 2, I'm going to use 2 and 1. If I was to put the 1 here, okay, that would be 1y, and that would make this 6y. Okay, because I would have the 2 here, and 3 times 2 would make that 6. That's going to be way more than 1. Okay, that won't subtract to give me 1. So instead, I'm going to try putting the 2 here and put the 1 here. So let's check the inner and outer products before I put the signs in. So this is 2y and this is 3y. Well, they will subtract to give me 1. I just need to ensure that the 2 is negative, and I need to make sure that 3 is positive. So that tells me where I need to place my signs now. So in order for me to get an outer product that's a positive 3y, I need the plus to go here. And in order for me to get an inner product that's a negative 2y, I need the minus to go there. And that is the exact same factorization that we had here. So the process may go quicker with trial and error, but it does allow for room for more mistakes. That's the only thing. AC method gives you an exact step-by-step method to do or to use. Okay, so let's do number 4. Let's do another problem. And I'll tell you what, because I don't have a lot of room there, I'm going to just kind of rework it on some paper, kind of just rewrite it on some paper here. So we're saying factor, and I'm going to do trial and error, and I'm going to do AC method. Okay, so let's start with AC method. So A is 5, B is 11, C is 2. Okay, so A, B, C. And of course, you take the sign with them. Okay, positive 11, positive 2. And of course, the leading coefficient is positive. All right, so A times C. AC method says I multiply A times C. So that would be 5 times 2, which is 10. So I'm looking for the factors of 10 that add to give the B term, the middle B term. Okay, So I'm looking for factors of 10 that will add to give me that middle B term. So factors of 10, 10 and 1, and 10 plus 1 does give me 11. So I know that's the one I'm going to use. But let's say you didn't recognize it. Another way to factor 10 would be 5 and 2. I'm sorry. Yeah, 2 and 5. I wrote 2 and 5, so let me say that like that. But 2 and 5 added together gives me 7. So that won't work. So I'm definitely using this pair right here. So I'm going to write 5z squared plus 11z plus 2. And then I'm going to break apart this middle term. Now, take note of where your numbers are, okay? And think about what you're going to have to try to do. You're going to try to factor out, once you have these two new terms, you're going to try to group the first two and group the last two. So when I put these new factors in, when I put in my new expressions for 11z, I want to put them in a place so that I'll be able to pull out that 5, okay? So I'm using 10 and 1. So I'm going to put the 10 here because that's a 5 right there. So I'm going to put 10z and then plus 1z. And then I got, or just plus z, and then I got plus 2 right there. Okay? So now we have 4 terms because we expressed that middle term as 2 terms now. And again, you don't have to show that one. That's just a z, a 1z or just z. And we're going to do factor by grouping. Okay? Factor by grouping. So I group my first 2 terms and I group my last 2 terms. Okay? When I group the first 2, and I'm just going to move this out the way for a little bit. When I group the first 2, I'm looking for a GCF that can come out of both of these. It's going to be 5, and it's going to be a z. That leaves me with a z here, because this was 5z squared, so I'm left with 1z. And then from this term, when I pull out 5z, I'm left with a plus 2. Over here, z plus 2 have nothing in common except for 1, so I'm going to show that I'm able to pull out a 1. And that leaves me again with just z plus 2. And look, your common binomial, and then you've got the factors that you pulled out. You're going to create a binomial with those times the common binomial, and there's your factorization. So again, this is the AC method, okay? AC method. I am going to now use the trial and error method. So this is where I take that same, so let's kind of draw a little line here. I take that same problem, 5z squared plus 11z plus 2, and I use the trial and error method. Which means I go right into my binomial factors. There's no GCF. I go right into my binomial factors. I draw my parentheses, in other words, okay? So then I say, well, I always start off with factoring the first term, 5z squared. 5 is prime. The only way to factor 5 is 5 and 1. So I have 5z and 1z, okay? Then I examine what my signs will be. If they're the same, I can go ahead and place them because they're the same. If they're not the same, I wait to place them and I put the numbers in first. So this is a positive C term, which means I have like signs. Okay? So they're both positive. Like signs, the middle term is positive, so they're both positive. So because they're both positive, we can go ahead and put them in. It does not matter where they go. They're both the same. Now I look for the factors of 2. Now, if there's more than one factorization of 2, you may have to play around. But luckily here, there's just one factorization of 2, 2 and 1. Okay? Where I place them is important though. So remember, you're trying to get 11z for your inner and outer products. So when I check my inner and outer products, they're supposed to add, because I have like signs, the inner and outer products are supposed to add to give me this 11z. So where I place them is important. So I can't put the 2 here. If I put the 2 here, that would give me 4. Well, I'm sorry, not 4. That would give me 2z. And then this would give me 5z, which would only give me 7z. I need 11. So I'm going to place the 2 here, and I'm going to place the 1 here. That gives me 1z plus 10z, and together that gives me 11z, that middle term. Okay? So your factorization is 5z plus 1 times 1z plus 2. So you know that you did it correctly. Okay? Whether you go trial and error or you go AC method. Okay? All right. Let's see. What else do I want to look at? Let's do one more problem here, like this. Because I want to make sure we're good. I think this is probably the hardest with factoring, the hardest topic here. Let's look at when you got the trinomial and the leading coefficient is something other than 1. So this example, we've got 2y squared plus 17. Messed up. I'm getting a sheet of paper. Let's rewrite that. 2y squared plus 17y plus 15. And it says factor also. Okay. So with this one, I'm going to use AC method first. I'm going to do both methods. So let's examine. A is 2, B is 17, C is 15. Okay. There is no GCF, so you go straight to your trial and error method. And this is blurry. Why is this not clearing up? Okay. So there's no GCF, so you go straight into either your trial and error method or your AC method. So AC method says that I multiply 2 times C, or A times C, which is 2 times 15. And in this case, that is 30. And then I find factors of 30 that add, and sometimes you have to say subtract, just depending upon if you have different signs. So let me say add slash subtract. In this case, we have the same signs, so it's going to be add. That add or subtract to give us 17, the middle term. Okay? That add or subtract to give us the 17, which is the middle term. So let's see. Factors of 30. Take a look. It's going to be the 2 and the 15, the numbers that you actually have. That's what you're going to use. So factors of 30 that we're going to use, 2 and the 15, because 2 plus 15 does give us 17. So those are the factors that I'm going to use. So I take this 2y squared, this 2y squared plus 17y plus 15. I take this original trinomial and I'm going to rewrite it with 2 new terms in place of that 1 middle term. So I still have the 2y squared, but instead of having 17y, I'm going to use 2y and 15y. Okay. And it's important where I place them. So I look at the constants that I have. Remember, in factor by grouping, you want to be able to pull out a GCF from each pair, from each binomial pair. So I'm going to use the 2y over here because I have a 2y squared there. So I'm going to put the 2y next to it, and then plus the 15y next to the plus 15. That way I know a GCF will come out of this pair and will come out of this pair. So now we have 4 terms. and we're going to do grouping. So we group the first two, and we group the last two. Okay. Now I'm able to pull out, look, I'm able to pull out 2y. That leaves me with y plus 1. Because remember, you always pull out the greatest common factor. So not only were we able to pull out a 2, but we were also able to pull out a y. And then over here, I'm going to pull out 15. And then I'm left with y plus 1. So my binomial, that's matching. I write that once times my binomial of the two terms that I pulled out, 2y plus 15. And there's my factorization. Okay? So this is what you'll do with AC method. Now, trial and error method works as well. So we can also use the trial and error method. So I'm going to do a trial and error problem using trial and error method here. Same problem, but I'm going to use trial and error. So I'm going to rewrite, and it just says factor. And remember, you choose the method. You do not work both of these methods, okay? You're just trying to factor it one time. I'm just showing you both methods, okay? Let's not get that confused. I'm just showing you both methods. So always look for a GCF that could come out of all terms. We don't have one. So then I go right into my binomial factors, okay? I always go ahead and I factor the first term. 2 is a prime number, so I've got 2y squared. The only way to factor that is 2y and 1y. Okay? Then I examine my signs here. We have a positive C, which means I have like signs. Okay? Positive C indicates like signs. And then the middle term tells us what they are. So we have the same sign or like signs, they're both positive. Because they're the same signs, I can go ahead and put those in, or we can wait. It's up to you. Now, what I'm going to do now is examine 15 here. I'm going to look at this. Keep in mind, I'm using factors of 15, and sometimes there's more than one. So factors of 15, we may have to see which ones to use. So we know 15 and 1, 3 and 5. That's really it. Okay. 15 and 1, 3 and 5. So I'm trying to get 17 for the middle term. So that means the inner and outer products need to give me 17. Okay. So let's play around. Let's say we tried 3 and 5. Okay. Let's say we didn't know. Let's try 3 and 5. If I use 3 and 5, if I place the 5 here, that would give me 10. 2 times 5. And then if I was to place the 3 here, that would give me 3. 10 and 3 gives me 13, not 17. Okay? And even if I was to reverse that and I put the 3 here, that would give me 6, and that would give me 5. 6 and 5 would be 11, not 17. So 3 and 5 won't work. So I have to use 15 and 1. So let's see where it needs to go. If I put 15 here, that would give me 15 times 2. I want a pencil. Let me show you here. If I use a pencil here, I can erase. So let's say I was to put 15 here, and let's say I was to put 1 here. And I wrote lightly because I want to be able to erase them if I have them in the wrong spot. So definitely use pencils, okay? This will give me 30y. This will give me 1y. 1y and 30y is 31y, not 17. So I can't use 15 here and 1 here. Let's erase that, and let's see if I switch them, what happens. Because I already know it's got to be 1 and 15, because the 3 and the 5 is not big enough to give me 17. So let's try this time placing the 15 here and the 1 here. That gives me 15y. This gives me 2y. And together, 15 plus 2 is 17y. So I have the factorization right, and I have like signs, and they're both positive. Positive 15y, positive 2y. When I place the 1 there, I get 2y, gives me that 17y. So my factorization is 2y plus 15 times y plus 1. Okay? There's one more problem that I want to look at, and it's where you have a perfect square trinomial in two variables. So I want to examine this one, and then I think that's pretty much the gist. The hardest part, I thought, were these problems because you do have to use either AC method or trial and error. And I've had in the past where students kind of tended to struggle with the trial and error method. So if you prefer AC method, go with that. Okay. Let's do one more. And this time we're working with, so I'm going to pull this out the way here. This time we're working says factor, so still factor. And this time it's y squared minus 14xy or yx. Yeah, I think let me do that. Let me rewrite that. So let's say factor. Let's have y squared. Let's go with minus 14yx, since the y is first there. And then plus 49x squared. Okay? All right. So first off, of course, you always look for a GCF. We do not have, let me kind of move this out the way. It's tending to be blurry here. Come on. Need you to clear up and stay clear. Okay, that's better. All right. So the first thing I'm going to do is go into my binomial factors. The leading coefficient is just 1. So y squared factors, that's just y times y. Okay. Now, looking at the signs here, even if you don't want to put them in right away, you do have a positive c. I want you to notice that means we have like signs. And I want you to notice that that last term, just like the first term, is a perfect square. So this is a perfect square trinomial in two variables. So 49 is a perfect square, x squared. 49x squared is a perfect square, and so is y squared. Okay, so to factor 49x squared, I'm going to use 7x and 7x. Okay, and then like signs, and they're both minus. So double check inner and outer products, because remember the FOIL method or the factoring is just foiling in reverse. When using trial and error, this is just foiling in reverse. So the inner product and the outer product together add up or subtract, depending upon your signs. In this case, they add together to give us the middle term. So negative 7xy or negative 7yx and a negative 7yx. Together, we get a negative 14yx. And keep in mind, yx or xy does not matter. It's a product. So which variable you list first does not matter. Okay? All right. Let me see if there's anything else that I wanted to go over. And I think that wraps it up. Make sure here. Here's one more. Let's do this one. And then this will be the last one. It says factor or u squared minus 28u minus 72. We're working with some pretty large numbers here. Okay. Now, if you have a GCF, of course, you would pull it out if you could, if there is one. So I'm looking at these numbers. I know 4 can come out of itself. I know 4 can come out of 28. And I know 4 can come out of 72. Okay? Look at my calculator. 72 divided by 4 is 18. 28 divided by 4 is 7. And of course, 4 divided by 4 is 1. So I'm going to pull out, before we do anything, factor out a GCF. Always, always do that. That's why I wanted to work this, to make sure that you recognize to look for a GCF first. So when I pull out the GCF, that leaves me with u squared minus 7u minus 18. Excuse me. Because again, 28 divided by 4, because when you factor out, that's just division. 28 divided by 4 is 7. 72 divided by 4 is 18. Okay? So the factor of 4 just kind of hangs out. And I'm going to use right into the trial and error method. Okay? I don't have to use AC method this time because the leading coefficient is just 1. So it's a bit easier to factor. Excuse me. So u squared factors as u and u. My constant term is negative. Negative C means I have different signs. Okay? Now, because I have different signs, I look at the middle term, and I know that the factors that I use have to subtract to give me that middle term. Excuse me. Oh, goodness. So I do have different signs, but because these are the exact same, I can go ahead and put them in. It doesn't matter where they go because they're the same. Okay? So I'm looking for factors of 18 that will now subtract to give me 7 because I have different signs. So factors of 18. Let's see. We got 18 and 1. We got 6 and 3. And then we've got 9 and 2. 9 and 2. I need to get 7. So I need to use 9 and 2. Okay? And I need to get a negative 7. So that means the 9 needs to go with the negative and the 2 needs to go with the plus. And there we have it. Okay? So again, I just wanted to come to you to just show you some more, more problems here. And hopefully this helped and that you'll be ready to take your exam. Have a good day.